All right, this is Tommy and Matt, and we're going to explain topic one. So we're going to start off with, I believe, page 549, number two. Then Matt's going to move on with number one on page 553. All right, so number two. So it first asks us to identify the patterns in each of the graphs that they give. So we either have a positive, a negative, or a no correlation for these patterns. So let's start off with letter A. So as we can see, all the data points are just skewed across the graph, and they're in every which way. So we're gonna go with no correlation here because really we don't know any direction it's going. It could be in the positive direction, it could be negative. So we have no clue. So we're gonna go no correlation there. For B, it's all the points are generally going in the positive direction. So the pattern here is positive because they're all going up diagonally towards the positive end. For C, all the data points are going down. So it seems that it's in a negative correlation because all these data points are going that way. And then for D, this is also going to be positive because similar to B, all the data points are just going up in a positive direction. For E, it's the same thing as C. They're all going down. There's an outlier here which may skew it off, but generally it's all these data points make it negative. And then for the last one, it's kind of close between no correlation and a positive pattern, but overall I think it is definitely a positive pattern because most of the data points are going up rather than just all skewed. For the next part, it asks the strength of the relationship. This can either be 0, weak, moderate, or strong. So for A, really the strength of the relationship is like how close all the data points are together. So I'll explain to you later with better examples, but we'll start with A. So here the strength is 0 because all the data points are just randomly placed throughout the graph. So we don't really know where any of these data points are or how they're related. So their strength is 0. For B, they're kind of all together, but really they're not in a straight line at all or very close together. So we're going to say weak. It's not 0 because if it was 0, they would probably be a little bit farther apart from each other. But yeah, in no way are they moderate or strong. For C, all the data points are pretty close together. We have this one outlier, but we're not going to worry about that because most of the points are together. So for this one, we're going to say moderate. It's not completely strong because they should probably be closer together, as we'll see in E. But yeah, that's probably moderate is probably a good bet. For D, we're also going to say moderate because they're pretty close together, but they're not like exactly close together, which in E we see is strong because this is basically in a straight line. Like you could literally write a line there, and it's right there. So and then lastly for F, it's also going to be moderate because the data points aren't super super together as we could see in E, but again, they're not 0 or weak. So moderate is probably a good bet. So for the next part of the question, we're going to look at whether the relationship is linear. So if it's in a line. So starting off with A, it's not going to be linear. This is because you can't draw a line anywhere here. It could be anything. So because it's no correlation or anything, it's not going to be linear. For B, it's very weak, but yes, it can be linear. It's very close to not being linear. If data points were a little farther apart from each other, then it would not be. But overall, it's probably linear. For C, it's very close, but we decided on not linear because if you were to draw a line here, it would kind of be like a curve, and you also have this outlier. So overall, it's probably not a line. Like it would be very rough. So rather than saying roughly linear, we went with non-linear. And then for D, we're going to say linear because you could draw that line right there. E, definitely, because it's a very strong relationship. You could see that it's going to be linear as well. And then for F, it's kind of similar to C. It would be a curve. So we're going to say non-linear for that one. And for the last point, whether there are any outliers. A, there are no outliers. They're kind of all outliers, so there's no outliers there. And then for B, also no outliers. They're all pretty much together. C, there's definitely this one outlier right here. D, there's no outliers. They're all pretty much the same. E, there's just one outlier around here. And then F, they're all pretty much in the same way, so there's no outliers. So now I'm going to give it off to Matt, and we're going to talk about number 2. Go ahead, Matt.
Welcome. So, for the second part, or question 1, it says, it asks us to match each scatter diagram with the correct value of R. So a little background, the R value here that they're talking about is essentially the strength of the correlation of all these data points. So each data point in all these examples, how well they correlate produces a certain R value between which R is between 1 and -1. We can see here that for A, we have probably a moderate positive correlation that has an R value of 0.6. So we know that this is moderate because it's rather close to 1. So it does have a rather strong correlation. Looking at B, all these data points are in a straight line. So this is a positive correlation that is very strong with an R value of 1. Moving on to C, with the negative correlation of that is probably a moderate negative correlation because they're rather close together. The R value that's produced is -0.7. So this also proves that it has a negative moderate correlation. Looking at D here, there really is no correlation. You can't tell if it's going positive or negative or any which way. So this has to be 0 because there's no correlation. Then if we look at the last example, E, where it is a straight negative line, we know that a negative correlation has to be, of course, in the negative. So the R value, or the strength of the correlation, is a -1 in a straight line. Bless up.